Uh, Dear students, once again I welcome you to the course on Six Sigma, and today we will discuss the solution of assignment 5. You have gone through various concepts on measurement system analysis and operating characteristic curve during last week, and we have offered you an assignment to revise and revisit your concepts. So, let us see the solution of the questions. So, there were 15 questions, and the questions were of objective type, and question number 5, 6 and 7 were common data questions. Question 1, systematic errors can be removed by A, recalibrating instrument, B, purchasing new instrument, C, cleaning instrument, and D, all of the above. So, the correct answer is A, recalibrating the instrument. This is the only way by which you can rectify this particular systematic error, and you can set your instrument back to the original calibration and accuracy, and recalibration is the need. Question 2, a measurement which provides degree of closeness of agreement among a set of results is called accurate measurement, average measurement, estimated measurement, and precise measurement. So, it is a very easy question, and you can understand that the correct answer is D. Closeness to each other is basically the preciseness, and it is precise measurement. Question 3, pick the correct sentence. Reproducibility means the closeness of output readings when the same input is applied repetitively over a short period of time with the same measurement conditions and same instruments. Second, repeatability means the closeness of output readings for the same input when there are changes in the method of measurement and condition of measurement. A, both 1 and 2 are correct, B, only 1 is correct, C, only 2 is correct, and D, both are incorrect. So, the correct answer is D, both are incorrect. What is the correct statement? For repeatability, it means the closeness of output reading when the same input is applied repetitively over a short period of time with the same measurement condition and same instruments. If you look at reproducibility, means the closeness of output readings for the same input when there are changes in the method of measurement and conditions of measurement. So, if you have done the experimentation in a particular setting and you are expecting the repetitiveness, it is repeatability, but let us say there is change in condition. Suppose you have conducted some survey in one state of India, and with the same instrument you are conducting the survey in other state, and if this instrument is able to produce the same results or close to that, then it is reproducibility. Question 4, looking at the following shooting target, how would you define the shooting of this competitor? Accurate and precise, inaccurate and imprecise, inaccurate and precise, accurate and imprecise. So, obviously the answer is C, inaccurate and precise. Now, we have common data question. Common data for question 5, 6 and 7. Conduct a gauge R&R study of the following data where 5 parts are evaluated thrice by 3 workers. You have 3 parts, and you have total 5 parts, 1, 2, 3, 4, 5, and if you see there are 3 workers, worker A, worker B and worker C, and the set of readings basically are taken. So, here what we can see that thrice the readings are taken for 5 different part and a particular worker combination, and you are also given in the table D2, that calculation of D2 some values in gauge R&R studies. So, number of observation in sample as you have studied 2, 3, 4, 5 let us say, and factor D2, these are the standard tabulated values, and we are taking it as it is as per the need. It means what is our sample size. So, question 5 is that what would be the value of sigma repeatability and sigma reproducibility and the answers are on the screen: 5.49 and 4.38, 4.56 and 4.74 and so on. So, the correct answer is B, that is 4.53 and 4.74. Let us look at the solution. So, you can easily compute the x bar, that is the mean value, and you can just focus on worker A part 1. So, I am just taking the average 112 plus 114 plus 116, and this average comes out to be 114. Same way you can compute the average for all the part and worker combination, and then you have the range R. So, next means next row after x bar is R. So, x max minus x mean. So, for worker A part 1 it comes out to be 4. Same way you can compute for all the combinations. X double bar, overall average value I can compute by taking the average of all the readings, x bar readings, and this comes out to be 104.66 for worker A. Similar way 102.98 for worker B and 111 for worker C. Similar way I can compute the R bar. So, it is the average of R value for each particular worker, and for worker A it is 9.2, worker B it is 5.2 and worker C it is 8.8. Once this initial computation is done, you can calculate the sigma repeatability and reproducibility. So, repeatability is basically R bar, that is the average of 9.2 plus 5.2 plus 8.8 divided by 3, that is 7.73. So, repeatability is R bar divided by D2, and hence it is 7.73 divided by 1.693, because here the sample size is 3 and for 3 sample size it is D2 is 1.693. You can see it in the table here. For 3 it is 1.693. So, sigma repeatability value is 4.56. Similar way sigma reproducibility is computed as R x double bar divided by D2. So, R x double bar is equal to x bar max minus x bar mean, and this can be computed. So, 111 minus 102.98 divided by 1.693, which comes out to be 4.74, and as I mentioned D2 is taken from table 1. Question 6, again we are using the same data. What is sigma R and R? So, the options you have are A 6.56, B 7.31, C 5.64, D 4.54. So, sigma R and R is basically square root of sigma square repeatability plus sigma square reproducibility, and you already know the value of sigma repeatability and sigma reproducibility. Putting it in the equation, you will get sigma R and R 6.57. Now, find out the value of P by T, precision to tolerance ratio for worker C. You have 4 options: A 1.032, B 1.505, C 1.395 and D 0.720. So, the correct answer is D 0.72, and the formula for P by T is 5.15 sigma R and R divided by tolerance. Sigma R and R we have computed 6.57, tolerance USL minus LSL, and 132 minus 85 is 47. So, I will get P by D 0.72. Question 8, which of the following statement is wrong about acceptance sampling plans? You have various options, total 4 options on the screen. A, acceptance sampling is a major component of quality control and useful when the cost of testing is high compared to the cost of passing a defective item or when testing is destructive. B, acceptance sampling is a process which requires the inspection of each individual unit or component received from a supplier to determine specification and quality compliance. And C, acceptance sampling is to develop inspection plans that enable you to accept or reject a particular lot of incoming material based on the data from respective sample. And D, acceptance sampling gives no idea about the process that is producing those items. So, you can see that the answer is A, acceptance sampling is a process which requires the inspection of each individual unit. So, we are basically expected to find the wrong statement, and wrong statement is So, here there is small correction, I would say the incorrect statement is B, and here you just correct it, this particular answer is B not A. So, if we have to do the 100% inspection, then what is the need of acceptance sampling? So, this is the incorrect statement. Question 9, fill in the blank is the probability that a lot containing acceptable quality level will be rejected. Then it is consumer's risk, producer's risk, acceptance quality level, none of the above. So, here you will say it is consumer's risk, that is A, that is the probability that a lot containing acceptable quality level will be rejected. So, we are just trying to appreciate the various dimensions of the operating characteristic curve. 100% inspection is not useful because it is very expensive. Inspection may be very tedious, so defective items may slip through even 100% inspection. It is a time consuming process. So, statement 1 and 2 is correct, statement 1 and 3 is correct, statement 2 and 3 is correct, all statements are correct. So, here answer is D, all statements are correct, and you can see that it is very expensive, it is time consuming, and it may be very tedious, so defective item may slip through even 100% inspection. Now, question 11, for cheap manufacturing company following data has been observed, lot size is n, that is 10,000, sample size small n is 50, acceptance number is 4, if the single sampling plan is taken into account and number of defect observed is 5, then accept the lot, reject the lot, take another sample, can't say. So, answer is B, obviously reject the lot. Question 12, you are supposed to match A, B, C with 1, 2 and 3, and let us say there is single sampling plan, double sampling plan and sequential sampling plan, and how basically it operates. So, on the right side your management specified 2 sample size N1 and N2 and 2 acceptance numbers C1 and C2, likewise you have 2 and 3. So, the correct answer is B, that is A2, B1, C3, and what we can say that single sampling plan decision rule to accept or reject a lot based on the result of one random sample from a lot. Double sampling management specified 2 sample size N1 and N2 and 2 acceptance numbers C1 and C2, and sequential sampling plan consumer randomly select items from the lot and inspects them one by one. Question 13, which of the following statements is or false referring to operating characteristic curve? It is a graph of the 100% defective in a lot versus the probability that sampling plan will reject the lot. Curve indicates discriminating power of the plan and measures performance of acceptance sampling plans. So, various options that only statement 3 is false, statement 1 and 2, 1 and 3 are false, 1 and 3 are false, and only statement 1. So, you can see that answer D, only statement 1 is false. Let us once again see what is statement 1. It is a graph of the percent defective in a lot versus probability that the sampling plan will reject the lot. Actually, it is a graph of the percent defective in a lot versus the probability that sampling plan will accept the lot. Question 14, in a lot size of 20,000, probability of acceptance is 0.483 and sample size is 20 and fraction defective is 5, calculate average ongoing quality. So, you have options 0.241, 0.41, 2.41 and 4.45. So, your correct answer is C, that is 2.41, and AOQ basically is PA into Pn minus n divided by n. PA is the probability of acceptance, that is 0.483, and let us say lot size is 20,000, n is equal to sample size 20, P is fraction defective. You can plug in the values in this formula and you will get AOQ is equal to 2.41. Now, last question, question 15. Pick the correct sentence. Type A OC curve is the probability of acceptance for an individual lot coming from finite production. Type B OC curve is the probability of acceptance for lots coming from a continuous process or finite size lot. So, the various options are on the screen and the correct answer is A, both 1 and 2 are correct. So, I hope this assignment would have given you the good revision and recap of the various concepts you have studied in the lecture on measurement system analysis and operating characteristic curve, and if there is any doubt you are free to ask or raise a question on Google forum, and I wish you all the best for practicing the various concepts of Six Sigma in your real life or day to day say examples or practices. Thank you very much.